Hi, my name is Mr. DeRosier. I am the content specialist for Algebra 2, and the purpose for this video is to help all the Algebra 2 students get ready for the upcoming Fall Common Assessment. This is one of two videos that I'm going to film. In this one, we're going to focus on the calculator inactive part of the Common Assessment. The questions that we're going to look at right now are the questions, the exact questions that you would have seen last year on the Fall Common Assessment if you were enrolled in Algebra 2. And the goal here is to share with you the techniques that you would use to solve these problems, talk a little bit about the way you need to organize your work and present your answers, as well as how points would be awarded. So let's get rocking and rolling. Remember that this is the calculator inactive part of the test. So on question 24, it says on the grid are 8 points from two different functions. Okay, we've got two different functions going on here. I'm not trying to connect the points. A certain linear function, linear functions, we know about linear functions, passes through exactly 4 of the points shown. And then a certain quadratic function passes through the remaining 4 points. All right, as soon as I think linear function, or as soon as I hear linear function, I'm thinking like y equals mx plus b, which is slope-intercept form. For a quadratic, I might think about y equals ax squared plus bx plus c. Or I might think about y equals ax minus k if you want to think about vertex form. I'm just marking this up. Those may be helpful, they might not be helpful, but these are the connections that I'm making right now. I've got 8 points, 2 different functions. One of them is linear. Linear functions look like that. One of them is quadratic. Quadratic functions look like that. Let's look at part A. In part A, draw the linear function on the grid. Use function notation to write an equation in slope-intercept form. Slope-intercept form, that's this y equals mx plus b that we pointed out earlier. So I need to draw the linear function. Now I've got a whole lot of points here. So I might connect a whole lot of them. I might connect those. I might connect to these two. But here's the thing. I need to connect. That linear function is going to pass through exactly 4 of the points. So take a second, look at the points, try to find 4 that you could connect with a line. No, not there, not there. What should be is these 4 right here. I know I'm blocking them out with my thick black pen. Maybe you want to grab a piece of paper, and if I just line them up, I can see that those 4 right there are all connected by the same line. That was the line I'm looking for. I'm going to draw my arrowheads always to indicate there's my line. Draw the linear function. Done. Use function notation to write an equation in slope-intercept form. Now, a little bit tricky in that I have my 4 points, but none of them are a y-intercept. It's not where I'm crossing the y-axis. To find the slope, hopefully at this point in Algebra 2 we're really comfortable. Slope is change in y over change in x, or it's y2 minus y1 over x2 minus x1. Any way that you want to do that is fine. We're going to pick 2 points that are on that line. I see this point here is at 4, 5. I see this point here is at 5, 3. And y2 minus y1, 5 minus 3, over x2 minus x1, 4 minus 5. I get 2 over negative 1, which is negative 2. That's my slope. That's the m. What I know is that now in my equation, I can write this as y equals negative 2x plus b. In order to get the value for b, I either need to give you the y-intercept, which I didn't do, or you want to try extending the line and figuring out where I'm going to cross the y-axis. I don't recommend that you do that because you're going to have some guessing. Or you could take another point on the line, like 4 comma 5. I know x is equal to 4, y is equal to 5, and I'm going to plug those in here. So 5 equals negative 2 times 4 plus b, and I'm going to solve that equation for b. We get that 5 is equal to negative 8 plus b. Add 8 on both sides, you get b is equal to 13. Your final equation is y equals negative 2x plus 13. That is in slope-intercept form. And so we're going to call that one done. That would be a perfect final answer. I'd want to see a box around it so you draw your attention to it. We awarded 1 point for the slope. We awarded 1 point for the correct y-intercept. But in order to get the full 2 points possible, you would have to write the equation as y equals negative 2x plus 13, or if you like function notation, f of x equals negative 2x plus 13. Great, we're done. That was part A. That would be something that I would think is probably pretty straightforward for Algebra 2 students at this point in the year. So let's keep going. Let's look at part B. In part B, we're told to draw the quadratic function on the grid. Okay? Use function notation to write an equation in vertex form to model the quadratic function. Okay. We've got our linear function which passed through the given 4 points. Now I need a quadratic function that is going to pass through the other 4 points. Let's make sure we know where those points are. This guy here, there, and this last one over here. My quadratic function, that's the parabola that's going to make a U shape, should look something like that. Now, an important thing that I want to point out here is, yes, that's my parabola. We're concave down. I can see that. But this point over here, you might just assume that it's the vertex. And in this case, you'd be right. But in order for this point to be the vertex, in order to know for sure it's the vertex, what I'm going to do is I'm going to look at these other 2 points. These 2 points that are on the parabola have the same y value. And so that means that the vertex is on the vertical line that is midway between those two, right? That's your axis of symmetry. And so this point here is on that line, and the coordinates are 3, 9. This has to be my vertex. These other points, what is this? This one looks like it's 4, 8. This other one on the side is 2, 8. Those are points that are on the parabola, just like the point 1, 5. But 3, 9 is special, it's the vertex. Let's see why that's so important. In part B, it says use function notation to write an equation in vertex form. Vertex form, as we've already talked about, is this f of x equals a x minus h squared plus k. I don't like f of x here because I'm already using f of x. So I'm going to call this g, just some other function name. We know that the vertex is located at the point 3, 9. And so if g of x equals a times x minus h squared plus k, I can take the point 3, 9, plug it in here, and I'm going to see that g of x is equal to a x minus 3 squared plus 9. That's great. We're not done, and the reason that you're not done is just like before, we don't know what the a value is. The way that you're going to figure out the a value is you need to look at any of the other points that are on the parabola. For example, the point 1, 5. Since that's on the parabola, if x is equal to 1, y is equal to 5 in this equation. So that gets me that 5 equals a times 1 minus 3 squared plus 9. Solving this out, we get 5 equals a. 1 minus 3 is negative 2. Negative 2 squared is 4. plus 9. Subtract the 9, you're going to get negative 4 equals 4a. Divide both sides by 4, a is negative 1. So your final equation is that g of x equals negative 1, x minus 3 squared plus 9. And that was the perfect right answer. You were awarded 1 point for correctly identifying the vertex. And then the second point comes in for figuring out the a value. So if you get the vertex, you get a point. If you get the a value, you get a point. But you only get both points if you write your final answer as a function g of x, f of x, h of x, something like that. So that was it. That was question number 24. We still have 2 more to go, but what I hope you're seeing is that in both of these questions, these are really important skills that you've been developing in the course, and this is just an opportunity to pull it all together. All right, let's go. Question number 25. Let me fold my paper back a little bit. Let's take a look at question number 25. I love questions like these. Question number 25, solve the following. I've got, in 25a, I've got 1, 2, 3 equations. I have an x, a y, and a z. I have 3 equations. I have 3 variables. This is what we call a system of equations, and I know that you all have spent so much time in Unit 2 solving systems of equations. The goal here is to figure out what is x equal to. Okay, so just realized I made a little bit of a mistake. That's okay, we're going to fix it. So starting back to 2x plus y minus z is equal to 8, y plus z is equal to 4, and x minus y is equal to 2. As I already mentioned, we have 3 equations, we have 3 variables, we have what we call a system of equations. You will not be successful solving all 3 equations at the same time. Instead, the technique is to focus, if you want to do it this way, I'm going to use elimination, that's one of my favorite methods. I'm going to focus on these 2 equations and try to get one of the variables to get knocked out in the process. And then I'm going to focus on another 2, could be the last 2, it could be the first and the last, it's your choice, to get the same variable to knock out. So, first equation, second equation, third equation. I'm going to go to the side and I'm going to look at 2x plus y minus z equals 8 and y plus z equals 4. And now this is up to you. You can do a variety of things here, but one of the first things that I notice is that I have a negative z in the first equation, a positive z in the second equation, and what I know is that with equations I can add them together, and that's okay. 2x, there's no x here, that's 2x. A positive y and another positive y is 2y. The negative z and the positive z, those cancel out. 8 plus 4 is 12. What I've just done is create a new equation, the 2x plus 2y equals 12, that has 2 variables in it, x and y. But I also see over here that I have another one of my equations that has those same 2 variables. So we're going to bring those 2 together. And I know that 2x plus 2y equals 12. I know that x minus y is equal to 2. And now I want to work with these 2 equations to see if I can eliminate one of the variables. Let's see, it's not going to be as easy as before where you just add them together and things cancel out. But I do see a positive 2y here. I see a negative y here. And one of the things that you're allowed to do with equations is multiply by a constant as long as you do it to both sides. And if you do that, you get the new equation, 2x plus 2y equals 12. I guess that's not the new one. Here's the new one. 2x minus 2y is equal to 4. And if I add those together, 2x plus 2x is 4x. The positive 2y, the negative 2y cancel out. 12 plus 4 is 16. Well, if 4x is equal to 16, I can divide both sides by 4, and I get that x is equal to 4. Well, hold up, that's not the end of the problem. You know that x is equal to 4. I need the y value, and I need the z value. Well, we've got the equation 2x plus 2y equals 12, so that must mean that 2 times 4 plus 2 times y equals 12. If I clean this up, I get 8 plus 2y equals 12. Subtract the 8 from both sides, divide by 2, y is equal to 2. Now that you know that y is equal to 2, the only thing that left we need to figure out is what z is. And from way back in the beginning, we knew that y plus z is equal to 4. So if y plus z is equal to 4, and y is equal to 2, then it must mean that z is equal to 2. So your final answer, x is equal to 4, y is equal to 2, z is equal to 2. If you wanted to write it as a coordinate point, it goes x, y, z. So you could write it as the point 4, 2, 2. The way we awarded points is if you got any of these 3 values correct, you earned 1 point. If you got all 3 of them correct, you earned a second point for a grand total of 2 points on this problem. Not too bad. Probably took longer to explain it than to actually go through and solve the problem. But another one that I would hope you guys are picking up a good amount of points on. Let's move into the last part. Part B. You write it over here a little bit bigger. In part B, negative 2x minus 1, the absolute value is equal to 11. So you're trying to solve an equation that involves absolute values. And what I need you to remember is that when it comes to working with absolute value bars, they only do one thing. Well, I guess they do 2 things. When you talk about absolute value, like the absolute value of positive 6 is 6. The absolute value of negative 6 is equal to 6. Absolute value is a measure of distance from 0. The absolute value of negative 6 is 6. If I were to give you the equation absolute value of x is equal to 6 and ask you to solve it, what you do is you break it into 2 different branches, or at least the way I would teach my Algebra 2 students. If the absolute value of x equals 6, then x equals 6, or x equals negative 6. Those are your solutions. There's no more work to do. So what do you do over here in a problem like this one? We're also going to break this into 2 parts. We're going to say, well, if the absolute value of negative 2x minus 1 equals 11, then it means that negative 2x minus 1 equals 11, or it means that negative 2x minus 1 equals negative 11. We have to consider both options. So we're going to solve each equation, add 1 to both sides, negative 2x equals 12. Divide both sides by negative 2, you get x equals negative 6. In this case, you add 1 to both sides, and you get that negative 2x equals negative 10. Divide both sides by negative 2, and you get that x is equal to 5. Now, before you declare that those are the answers, there's an important check step that is critical when it comes to working with absolute values. Sometimes your equations introduce what we call extraneous solutions. And so the way that you go about checking for that is we're going to plug in x equals negative 6 into the original. You get the absolute value of negative 2 times negative 6 minus 1. We want to know, is that equal to 11? Well, negative 2 times negative 6 is 12. 12 minus 1 is 11. And the absolute value of 11 is 11. That worked. What we got when we evaluated the expression on the left is equal to 11. Try it again for x equals 5. If x equals 5, we get the absolute value of negative 2 times 5 minus 1. Well, negative 2 times 5 is negative 10. Negative 10 minus 1 is negative 11. And finally, when I take the absolute value of negative 11, I get 11. That is what I wanted. That is the expression on the right. So your final answer is x equals negative 6 and x equals 5. We awarded 1 point for each of those answers. If you didn't show the check step, you still were awarded the points, but you got lucky on this one. Anyway, thanks for sticking with me through the video. I hope you found this helpful. I don't want you to think that these are exactly the problems that you're going to see on this year's Common Assessment. It doesn't work that way. These are, however, really important skills that you can expect will be assessed on some point of the exam. Wish you all the best.